Yeah, we back and looking at ones and zeros, a Java exercise from Codewars. And yes, this is Codewars. I'm trying the daylight, the bright interface today. I usually use the dark one, trying something new here. Spice it up, my homies. All right. Given an array of ones and zeros, convert the equivalent binary value to an integer. And yeah, this is Java, this is not Python. So doing this in Java today. Language is Java, remember that. I need to remember it too, because I'm always doing Python. Anyway, 0001 is treated as 0001 in binary, which is the binary representation of 1. And then you got your examples down here. And really, you're simply converting a binary number to an integer, but the binary number is going to be in the form of an array instead. So, let's take this one out, and you can just think of it as 1, 0, 0, 1 in binary. And let's look at this one too. And generally, to convert binary to integer, you're going to do really I guess you get powers of 2, and you add them together. So like with this 1001, you really set up a situation where you do powers of 2 starting from the right and going to the left. And so like on this one, it would be 2 to the 0 power. This would be 2 to the 1 power. This would be 2 to the 2. And then 2 cubed. So each one of these is a power of 2. And you're only going to count the ones that have a 1 as their value. The zeros you can ignore. So really converting to binary, or converting from binary to integer, is simply taking each binary number, only the ones that are ones, getting the appropriate power of 2 for that slot, and adding them together. For instance, here we have ones at 2 to the 0, which anything to the 0 power is 1. And then we have 2 cubed, which 2 cubed is 8. So those two together are going to be 9. And there's your answer there. And you look at these. This one, you put a 2 to the 0 power. Here's a 2 to the 1, 2 to the 2, and 2 to the cube. And because these are all ones, you're going to add them all together. And remember, yes, when you have zeros, you basically ignore that spot. You only count the ones with ones. So coming back down here, 2 to the 0 power is 1. 2 to the 1 power is 2. Anything to the 1 power is itself. 2 squared is 4. And then 2 cubed is 8. So we add all these together. We have 3, 7, 15, 15. So there we go. There's a tiny tutorial in converting from binary to integer. And that's really what you got to do. You go through the array kind of however you want to do it, and you get the powers of 2 of each of the ones, and then you add them together. Now let's do it in code. Slide up in here. Yep. Got your Java boilerplate for the method. I'm going to be storing my integer total in an integer, so I'm going to create an integer for that. And then I'm going to begin looping through the array. The array is called binary, I believe, not non-binary, which is a big term these days. And remember I was saying when I was explaining the binary to integer conversion, you only need to count the ones. If you encounter a 0, you can just ignore it. So I'm only going to do something here if I encounter a 1 in binary. So that'll be my condition. If the value I encounter is a 1, then I'm going to do something. Of course, I'm going to get its power of 2. I wanted to say that the data structure for binary is not an array. It's a Java list, and that's why I'm using size and get, and not indexing. Just wanted to make that point because I said array before, but I realized that this is a Java list. Yes. Wonder why they're using list and not array list. Some people like to be fancy like that. All right. So if I encounter a 1 in my binary list, I'm going to be adding it to my total, but I got to do some stuff, and I'll type it up here and then I'll talk about it. All right. So what I'm doing here is I'm getting the power of 2 for the location of the 1 in the array. And for the location of the 1 in the array, I'm getting the size of the list minus 1, which means that's going to be the very last possible index. And then I'm minusing I to get the actual location of this 1. Let's look at an example here. Let's say you got 1, 0, 1, 1, and these are at locations 0, 1, 2, 3. These would be indexes. All right, so let's look at this one. Of course, we're already looking at it, of course. So binary size on this one is going to be 4, and then you minus 1. Of course, that gives you a 3. And then let's say I is this one. I is the 2. Let's say so in this I guess a formula here, it would be, I've already done size minus 1, so then I minus I, which is 2, and that is going to equal 1. 1 is the power of 2 that I need to use to do to this binary number. So it would be 2 to the 1, which is appropriate for its place, because remember I said going from the right to the left, you have 2 to the 0, 2 to the 1, and then going to the left. Well, we've determined that from this formula you get 1, and that's the power of 2 you use. So in this particular specific index, or not index, instance, that's the right word, this particular instance, this 2 would be raised to the power of 1. So there you go. And that's a little bit about what this formula does. All right, let me clear this out because I'm gotta wrap this one up, homies. Almost got it. Time for an appointment. All right, let's go here. Always working, always grinding. I think all I gotta do is return the total anyway. I think I'm good here. And there is your binary to number conversion. Let's see if this sucker works. Looking good, homie. All right, all right, all right. As McConaughey would say, we are looking good. I like it. Nice and wrapped up right before I got to head and do an appointment. Wish me luck, y'all. All right. Looking good. Okay. That's it. This is binary array. Actually, I was reading the method name. This is ones and zeros. A Java exercise from Codewars. And with that, good people, I am out of here. I almost said suckers. That wouldn't have been good. All right. See ya.